in the 1600s, when Newton was alive, he was sitting under an apple tree, as many of you have heard about, and all of a sudden an apple dropped on his head, and that's when this would lead to many of his discoveries, which would include the Newton's laws of motion.
An apple.
According to Newton's first law, or otherwise known as the law of inertia, objects not in motion will stay not in motion, and objects in motion will stay in motion unless acted upon by an outside force. So here's a book, but to clarify this idea that this book will not move, I'll have a second book right here. So here's another book, but I'm not going to have it at 2 books, I'm going to have a third book. So just to clarify this idea that these books will not move, I have 3 right here. So we could wait all day long, and unless an outside force acted upon it, they would not move. So we also have an object in motion, but due to outside forces like gravity and friction, and as well as a little bit of air resistance, this ball would stop moving. But if this ball was in space, it would keep going forever. This brings us to Newton's second law, which states that objects that experience a force and have mass will accelerate. So here's a tennis ball, and if I throw it into the air, it gains acceleration because of the force I applied to it. But due to gravity and air resistance, it's going to come down and lose its acceleration. No. Newton's second law can also be depicted by this formula, which is force equals mass times acceleration. So in Newton's third law, his final law, it states that for every action there is an equal and opposite reaction. And so when I'm jumping, I will apply force towards the ground, and it will apply the same force, allowing me to gain some height. So here, when we apply a force by high-fiving each other, the force will be an equal and opposite reaction. So when our hands meet, they will both stop. So Newton's third law can also apply to many things, such as, so when I push on this, I'm applying a downward force, but at the same time, this tabletop is applying an upward force. So this wall will do the same exact thing. While I'm applying a force this way, it's applying an equal and opposite force the opposite direction. So what did the bartender say to the neutron? No charge. No reaction?